Alright everybody, welcome back. Today we're going to talk a little bit about slope and what that means. We've been talking about linear relations, we started talking about functions as well, so now we're going to get all into the equation part of this. And that starts obviously with dealing with slope. So we're going to take a look at slope first. Now it might seem a little weird, but just by observation, if we look at these line segments, and we know they're segments because there's no arrows, we do see those endpoints on them. Given by those letters of the alphabet there in blue. The order of steepness from least steep to the steepest, and explain your reasoning why. So the least steep one is going to be the one visually that looks like the hill or the slope is not as high. So if you go in order of least steep, I guess it would be C to D. And you don't have to be perfectly right, but I think this is the order, with 4 being the steepest, almost vertical. Okay, now the steepness of this line, it can be determined by looking at the ratio of the change in the vertical values, or what we call the rise, how much we go up in a relation to our starting point, and to the change in the horizontal values, or the run, how much we change horizontally in relation to our starting point. Okay, in math, we call that steepness obviously a slope. And we can use the following formulas to find it. There are many. So the slope really is the rise divided by the run. How much you go up divided by how much you go either left or right. It can be also a rate of change, so speed over time, a distance over time. Or we represent it using this little symbol here, this little triangle. It's Greek letter delta. All it means that it's talking about the change. Okay, so this is the change in y, or the change in x. You might have seen this in science when you do the change in temperature. So temperature 2 minus temperature 1, or temperature final minus temperature initial. Same sort of thing happens here. Okay, this has a lot of applications in science as well. If we're actually going to go determine a couple slopes, and maybe I'll just do the first two and leave the last two for people to try. If we look at the first one, in order to figure out what the value of slope is, you have a couple ways of doing so. You can use, I don't know if we do the slope formula in a second here. No, okay, we can talk about it now. So there's a couple ways you can do this by visually looking at this graph and starting to count the rise and the run from one point to another, or you can use a formula. Now we'll do both for the first one. Now the 2 points that I can really see clearly that intersect, those perfect grid lines, or I know for sure what their coordinates are only A and B, right? Those are really the only 2 points that I can see that connect, perfectly with those blue grid lines. Now if I'm going to count out the rise and run from A to B, because remember we're going to read this graph from left to right, its rise, I have to go up 1, 2, 3, 4, 5, 6 units to get on the same level as B. Okay, so the rise, I had to go up, it was plus 6. The run then, from whenever I get to that point that's on the same level as B, I have to go over that many to get there. Okay, so we're gonna go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We went to the right 10 units. Going to the right on a graph really represents positive values. Okay, so the slope of this line is equal to whatever the value of the rise is divided by its run. So that's going to be 6 over 10. And we're going to reduce that slope into lowest form whenever we can. So this is going to be 3 over 5 as a slope. Could be fractional, that's okay. But if we go to use and test out what the formula actually looks like, the slope formula is really the change in y divided by the change in x. So I should have 2 different points in order to do this. I need to know both of their y coordinates and both of their x coordinates to figure out what the change is. Now, we're going to say that we take the second point and we subtract the first point. But we have to deal with their coordinates independently. So we'll take the y coordinates of both points, subtract them. We'll take the x coordinates of both points, also subtract them. But this, I have to subtract in the same order. So if I start by using point B as y2, x2 also has to be the x coordinate of point B. I can't mix and match partway through. So I need the coordinates first. So point B has coordinates of 4, 3 it looks like. So 4 comma 3. And for A, that'll be negative 5, negative 3. Okay, so there's my coordinates. 4, 3, and negative 5, negative 3. I'm going to let y2 and x2, I guess, that point, be point B. So x1 is 4, y1 is 3, x2 is negative 5, y2 is negative 3. So then we can just plug in our numbers as we see them into this formula. And the choice that you make there, it really doesn't matter. If you want to make the B point your point 2, that's okay too, as long as you let A be obviously point 1. And as long as you plug them in the right P. You really can't mix and match here. It won't work out. So y2 is going to be negative 3, and we need to subtract 3, okay, because that was what y1 was. So underneath, x2 is negative 5, and we'll subtract 4. Did I count something wrong? Maybe I counted the first part wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I look okay. Oh, it's my x coordinate here. I put negative 5 is supposed to be negative 6. That's why. So I counted that part incorrectly. So just make sure that you do take these slow. As you can clearly see, it does happen to us teachers too. Sometimes we do make those mistakes. Okay, but they should match. So I knew they didn't. I knew something was wrong because they didn't get a 10 on the bottom. But now we're good. Okay, so I get negative 6 on top. I get negative 10 on the bottom. But I started with positives both top and bottom. Now I know from integers that those negatives can cancel, and I can reduce this fraction. So this does reduce to 3 over 5. Oh, excuse me. Ugh. So there we go. It does work. I do get the exact same thing. So let's try B. Maybe we won't count this time. We'll just use the formula, because since that's the one I screwed up, maybe we got to make that really good. So if we look for those coordinates first, point C has coordinates of negative 3, comma 4. So there's my negative 2. So negative 3 is one more. 4 is up. 2, negative 6 is are the coordinates for D. So we'll take a look at that slope formula again. So let's give ourselves a little bit of room. So the slope is equal to y2 minus y1 over x2 minus x1. And we can substitute in our points. So it doesn't matter which one you call your first point or your second point, as long as you keep the order consistent. So let's make this x1, y1. And you don't have to label this every time. Really, starting out, it does help so you remember which one's which. But as soon as you get into a rhythm and figure out how this works, you don't have to label them every time. Okay, y2, what you said was 4. So 4 minus negative 6. The sign is important. This formula always has a negative built into it, a subtraction. So really make sure that if your y1 value or y2 values, if there was a negative, that negative has to come with it. Okay. Underneath, x2 is negative 3. x1 is 2. Okay, so this slope is not negative, positive 10 divided by negative 5. This slope is negative 2. Okay, so compare that to the one we did before. I had a positive value for slope, and you can see my line going up and to the right. Okay, if you read this from left to right, it goes up to the right, but if you look at it the other way, it could also go down and left. Okay, as long as one of the directions for my rise and run is positive, then we're okay. So if I read it from left to right, my rise is positive, we're going up. But my run, also positive. Okay, so both here have to be positive for this to be a positive slope. Or both have to be negative. So I could be going down and left also. Okay, I could have actually went, and maybe we'll write this out in that first one using the picture. I could have actually went 4, 5, 6. I could have actually went down 6 and all the way here, I could have actually done negative 10. So if I use those to generate my slope, negative 6 divided by negative 10 would actually give us, that positive. Very much so like it did using the formula. So both directions here had to be negative because it canceled to a positive. But if I do that for B, you're going to notice that one of the directions will be negative, and only one of them. Oops. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So down 10. 1, 2, 3, 4, 5. To the right by 5. If you do that the other way, then you're going up 10, left 5. So you can do this really in either of the directions. It will still work. So I'll leave C and D for people to try, and again I'll give you the full key in that description box. So there's 4 types of slopes that you're going to see throughout this course. Okay, you're going to see line segments that go up and right, or like we said, it could go down and left. Both the rise and the run are positive. That's going to give us what we call a positive slope. Okay, we talked about one that was negative just now, so the line segment goes either down and right or up and left. Okay, the rise is negative, run is positive, slope negative. All of these are based on the fact that we're reading that graph from left to right, which is perfectly correct. Okay, that's what it's based on, reading this graph from left to right. We could also see a horizontal slope, so those are the ones where you're going to see a run that's a positive value. I'm going to keep going horizontally, but we're not going up. Right? So think of this just like walking around the floor of your house. Right? Your house floor isn't sloped until you get to the stairs. Right? So that really would make it fun, not very nice, to walk on. Right? So that floor has to have a slope of 0. Now, if it's a vertical line, that slope is actually undefined. That would mean that my run is 0. We're not moving sideways. Right? But I know in math I can't divide something by 0. It gives me something that's undefined. It doesn't work. Okay, so those are the 4 types of slopes that we'll see. We can also draw them. So like if you're given a bit of information, we're actually able to create a line, and this is going to start creating all of those linear equations for us. This really is the beginning. M is going to be the variable that we give to slope. Okay, so if you see an M anywhere, we're going to reserve that letter to mean slope. Okay, in our next video will give us the equation that uses this. We'll call it slope-intercept form. Now some people might have heard of that already, but we'll make it a little bit more formal in our next video. So here's our point that we're going to use, -1, -1. So it's helpful just to plot that point first. So -1, -1 is right there. There's point P. Now if I'm going to use this slope to generate a line, I really have to follow the directions that the slope tells me. Really, it tells me that the rise is 7, the run is 5. So from this point, that point has to be on the line that we're creating. So that must mean from this point, I should be able to go up a certain number of units and run a certain number of units to generate a new point that's on the same line. Just like we saw above, we had a line segment, and we could create this. We could actually generate a whole bunch of points that would be on the same line. So from this point, we're going to go up 7 units. So let me just count this out here. 1, 2, 3, 4, 5, 6, 7. It takes us to about there. But I can't have that point there because that would represent a vertical slope. I also have to account for the fact that it's got to run 5 units over. Okay, so 1, 2, 3, 4, 5. My point should actually be here. I'm going to keep this point here just as a placeholder for now, and I'll show you why in a second. Now, from that first point we started with, my line is going to basically be positive, right? My run was positive, my rise was positive. That means if I go both in a negative direction, I'll get another point that's on the same line as my 2 original points. So if I go down 7, 3, 4, 5, 6, 7, and then over 1, 2, 3, 4, 5, there's a third point that is on the same line. And again, I kept that little dot there as a placeholder, so let me connect this line first. Okay, so connect them with a straight line as best you can. So there we go, it should be a line that goes through them. Now, it is a line, so it should have arrows. And the reason why I kept those other points there because if you were to 1, 2, 3, 4, 5, 6, if you were to actually count it out, you'd be going up 7, right 5 to get to your new point. Okay, so as long as you do that from the points that you've generated, you can make infinite number of points on your line. If I do that going the other way, now you wouldn't do this every time. You wouldn't need to explicitly show it. It might help if you're explaining something to somebody and trying to prove that yes, this slope does work. You might want to, but usually we don't write them on there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So we're going to go down 7 and left 5. So both directions if I look at the red one, both those directions were negative, still gave us a positive slope. Both directions were positive in the pink one, again, positive slope. So either direction you choose will still work. Okay, so I'm going to leave B and C for people to attempt. It's very similar to this, just different numbers for your rise and run, different points. So again, you'll have the full key as well. Okay, so this is where we kind of went for this before. Without having the graph, we can really do this if we have just the points, right? I don't really need to have a graph to do this. And we started looking at this before. So if I actually take these 2 points and I label them, and I just pick one to be, my first pair, pick one to be the second pair, let's maybe say this is x1, y1, x2, y2. And again, this really helps as we're starting this out. Helps us remember which ones and which numbers have to go where. Right? So our slope again is that change in y over that change in x, rise over run. So y2 minus y1 over x2 minus x1. Okay, now we can put the points in. So on the top are the rise values, so all of the y's. So 1 minus negative 3. Underneath is the x's, 2 minus negative 5. Okay, so on top you're going to get a 4, on the bottom a 7. Positive slope from each point to the next, you're going up 4 units, right 7. Up 4, right 7, up 4, right 7. You can keep making new points by following those directions. Again, I'll leave B for people to attempt. Okay. But there's pretty much slope. Really, this is what it is. An application of slope, you can also refer to it as a rate of change. So now when we have context applied, and we have specific things for our independent and dependent variables, we can really give this units, right? So all the other ones didn't have units because I just had 2 points in space. But now, if we're talking about something like volume and time, those units exist, so I should be using them. Okay, so we're asked to identify the independent and dependent variables and then determine the rate of change, describe what it represents. So if we look at part 1 first, independent, that variable is going to be time. Right? The independent variables are your x's, your domain, whatever you want to say there, but really it's time. Time is not affected by anything else. Time affects other things, but other things don't affect time. We can't stop it, we can't slow it down, we can't go backwards, we can't jump forwards. Right? Time's independent. Dependent is going to be the volume. Right? The volume is changing as a function of time. We talked about functions last time, so function notation for this then would be the volume as a function of time. Time is the input, volume is the output. Time is independent, volume is dependent. Another way to look at this. Okay, so number 2 then, when we're actually asked to determine the rate of change. Now, if I look at this graph, I'm going to be smart about the points I'm going to choose. Right? I'm going to pick this one, the maximum, because it's clearly identified as 6,000 for the volume, 120 minutes for the time. I'm also going to pick the origin, right? 0, 0. No time has passed, no volume. This is an empty water tank. So I can be smart about the points I'm choosing, and I can choose any 2 points that are on this line. Okay, so the slope then is our y's over our x's. Now the y value is 6,000 for the first point, but my y value for my second point is 0, so I'm just taking away nothing. Okay, the x value for my first point, 120, and again we're subtracting 0. So by doing this, that helps actually, make the numbers a lot nicer. Now let me just pull up a calculator here, make sure I do the subtraction correctly. And why is it not going where I need it to? I guess it can stay there, that's okay. So I'll just present that part, and then we can see the calculator there. So let's turn this thing on. Is it already? Perfect. So 6,000 divided by 120, 50 is going to be the value. My face is currently blocking it. That's okay, because let me shrink my head. There we go. 50 is going to be the value of this slope. That's what it works out to be. So 50. However, we had units. Okay, all of the y's have units of volume. So really on the top for our rise, we should have those units of volume as well. Volume. All of our x's had units of minutes. So really this is 50, not volume. Mr. Saw, come on. It says volume, the units are actually liters. Sorry, my bad. It should actually have liters, and then instead of time on the bottom, we're gonna have minutes. Okay, so what this really represents in this context is we can fill up this water tank at a rate of 50 liters per minute. So every minute that passes, we put up 50 liters of water into this tank. That's really what it represents. Okay, let's get rid of that for now, if I can. I don't know why I'm not able to. Please go away. It really doesn't want to move, eh? Okay. Is it gone now? No. I don't know why it's not leaving. Alright, we'll do that. Now it's gone. But it's still on my screen. And it really won't. Oh, there we go. Got it. Okay. So this graph shows the fuel consumption of a scooter with a full tank of gas beginning its journey. Okay, so I still have volume, but we're talking about the volume of gas now. Distance is now our x variable, kilometers. So let's go list out what we have. We have independent. Okay, that's going to be our distance. And our dependent is the volume. Okay, the farther I go, farther I travel, the less volume of gas I have. Right, so that volume is dependent on the distance traveled. Okay, let's go find the slope then. So, number 2, our slope equals our y2 minus y1 over x2 minus x1. Let's make this one y2. I'm going to choose, the endpoints there. 200 and 0, or, sorry, 200, 0, and then 0, 8. So if I write out what those points actually are as coordinates, x coordinate of 200, that one's 0. This one here, x coordinate 0, y coordinate of 8. Really, these are my intercepts, where I cross the y and x axis. And usually it's helpful to use 0 because it helps with subtraction. So if I subtract my y's, let's do 0 minus 8. So I took the 0 from my point here, subtracted it from my 8 from my other point. Now, when I do the x's, I have to do them in that same order. Since I started with this point, with the 200, that has to be the x value that goes first. Okay, 200, and then minus 0. So this is going to be negative 8 over 200. Which I don't want to play with that calculator again, so this is going to be, if I divide it by 4, negative 2 over 50, or I could have divided it by 8, I suppose, negative 1 over 25 as lowest terms. Okay, and again, this is a rate of change because I have units, so I need units here as well. So really, this is negative 1 liters every 25 kilometers. Okay, so for every 25 kilometers traveled, we use 1 liter of fuel, which is why it's negative. Our volume of fuel in the tank is decreasing. We're not adding anything in this time. We're losing gas because we need to burn it to travel on our scooter. But that really is slope, and that is its rate of change context and applications applied to it. So in the next video that you're going to see pop up here in a second, We're going to be talking about slope-intercept form, and we'll start to get into all the linear equations and how we can use them to generate new lines, change it into different formats. This is the beginning of systems of equations, which we're going to talk about as our next unit. So again, I hope these are helping. I hope you do enjoy them. If you are at home, you're sick, ill due to COVID, whatever the case is, I hope they do make a difference. So follow me on Instagram, follow me on Twitter. You have all the links to everything that you need here. If you do want to reach out, connect, ask any questions, by all means. Until next time, stay safe, and everyone have a great rest of your day. Take care.